All right, welcome to section 6.3. We are going to be looking at vectors. In mathematics, we have a lot of different ways that we represent different quantities, but some quantities need to be represented using vectors, and it's because they've got more than one thing that is in control of the situation. But we'll look at to see what vectors contain. First of all, some quantities that we represent are used with just a single number. An example of having something in mathematics that we just use a number would be time, area, or temperature. And then there's some quantities that use directed line segments, and those quantities are like force or velocity. Force and velocity a lot of times can be represented with discussing or talking about like magnitude. Magnitude here is the length of something, and the length represents its strength. And then direction is the slope of. Okay, so when we look at vectors, then both of these quantities are being represented, a specific direction, and then how strong is the relationship.
Hi, Sandy. Oh, sorry. Are you on the phone?
All right, so let's go ahead and continue with vectors here. We've got this is not in your packet, but I just wanted to show you a couple things with vectors. If I've got a vector that looks, let's go a little bit thicker here. If I've got a vector that is vector v, let's say it's just right here. This is vector v. Then 2 times vector v would be twice the length. And 3 times vector v would be 3 times the length. And negative v would be the vector going in the opposite direction, but yet the same distance. And half v would be half of the segment. So those are some things that vectors have characteristics, whether they are being multiplied by something or if there's the opposite of. All right, first example says, let vector v be a vector from the origin to the point 4, 5. Let me go ahead and plot this out. So there's the vector from the origin to 4, 5. And this is vector u. And, vector v. And u be a vector from 2, 3 to 6, 8. So let's go ahead and map that one out. 2, 3 to 6, 8. So what they want us to do is they want us to show that those vectors are equal to each other. Well, in order to show if vectors are equal to each other, there's 2 things. Number 1, that they have the same magnitude, and magnitude means distance. So believe it or not, we just use the distance formula. Okay? And the other thing that they would have is the same direction. So in order to find the same directions, we will identify the slope. All right, well, let's go ahead and do the distance formula for vector v. And you'll see the notation of vectors v, they kind of look like a little bit, a straight line with a little half arrow on top. And the magnitude of it looks like this. This is magnitude. So square root of 4 minus 0 squared plus 5 minus 0 squared. This is equal to the square root of 16 plus 25, which is the square root of 41. So the length or the magnitude of vector v is 41, square root. Let's find the magnitude of u now, vector u. Square root of 6 minus 2 squared plus 8 minus 3 squared. You can see here we're going to get the same numbers, 4 squared plus 5 squared. So this equals the square root of 41. So what we've shown so far is they have the same magnitude. Now, as far as the slope is concerned, slope of vector v equals 5 minus 0 on top. On bottom, 4 minus 0. So we get 5/4. And then the slope for vector u, 6 minus 3 over, 8 minus 3 over 6 minus 2 equals 5/4. So the slopes are also the same. So yes, they are equal to each other. All right. Looking at our next example, it says find the component form and the magnitude of vector v. Well, what component form is that you take an ordered pair. Let's say you've got a vector from the origin 0, 0 to 3, 2. Well, component form is, let's say this is point P and this is point Q. So the vector from P to Q would be equal to, in component form, what you do is you subtract. So you would subtract the 3 minus 0, comma, and then you subtract the 2 minus 0. So our vector in component form would be 3, 2. And what that really identifies is it identifies a location. All right, so here's how we actually find, or we can have a formula for it, find the component form and the magnitude of vector v. So component form right here would be the vector pq in component form would equal q1 minus p1 comma and q2 minus p2. And that's how it looks. All right, now magnitude. So let's find the component form of this vector pq. So negative 3 minus 4 is negative 7. And 3 minus negative 5 is 8. There's your component form. Now the magnitude. Okay, so if this is my vector, so the magnitude of this vector would equal the square root of, since we've already done the subtraction here, you've already done the negative 3 minus 4, so what we all have to do is just square the negative 7 plus, and this is already subtracted, so square the 8. This equals the square root of 49 plus 64, which is 113. There's the magnitude of it. Okay, let's try another example of that. If I give you A is the ordered pair 2, 4, and B is the ordered pair 3, 9, component form, if we have a vector that goes from A to B, so let's call it vector V going from A to B, then the component form would equal 3 minus 2 and 9 minus 4, which equals 1, 5. Now the magnitude of it, you use the distance formula, so the square root of, this is already showing the subtraction, so all you need to do is square the 1 and square the 5 and add them together. So this would be the square root of 26. The magnitude of v is the square root of 26, and the component form is 1, 5. All right, so there's some preliminary, just some very basic parts with vectors and some of the notation that we use. The last thing that we're going to do is I'm going to show you how you can do some sketching of vectors and how you can change by adding vectors together or subtracting vectors. So let's first look at taking a vector u and doing 3 times u. Before we begin though, our vector u here has component form of -2, 1. Okay, and vector v has component form of 2, 4. Okay, so let's first do 3 times u. So 3 times u would look like this. We're going to go ahead and put the vector u on the coordinate plane. So it's over -2 and up 1. Okay, so here's my vector u. So if I want to do 3 of those, then I just have to do left 2 and up 1 again from this point. So there's another vector u, and then left 2 again and up 1. So this is total are 3u, because each one of these represents a vector of u. So you have 3 of them. All right, now let me show you how we add. And actually, there's 2 ways that you can add vectors together. And that's what we'll look at next. So let's copy over our vectors of u and v. We've got -2, 1 and 2, 4. Oops. All right, so we're trying to add these together. We're going to do u plus v. So u plus v, what does it look like? We're going to do all of this on the coordinate plane. First of all, I'll show you both ways to do this. Let's go ahead and do, let me work back here, and this will be the first method on this side, and then this will be the second method. Both of them will represent u plus v. All right, if I'm at -2, 1, this is my first vector, and that's vector u, and then vector v is at 2, 4. Go ahead and label these vectors. This is u, this is v. Now the sum of the 2 vectors, it's found in 2 different ways. So the first thing that we're going to do is create a parallel line here. You do a parallel line with vector v, and you can do a parallel line with vector u. And when they cross, then the addition of the vector is the segment that starts at the beginning and ends where they cross. Okay, so this is vector u plus v. All right, that's one way to do it. Another way to do it is you start with the first vector here. So this is vector u. And then from vector u, you do vector v, and vector v is to the right 2 and up 4. So you go to the right 2 and up 4. So this is vector v, starting at the end of vector u. So the answer would be, again, from the starting point to the ending point. Right there. This is u plus v. And obviously we would have the same result here. I just, my drawing's off. All right, so that's how you do addition. There's 2 ways to do addition. You draw the first, draw the second, make a parallel box, parallelogram and then connect the diagonal. Or what you can do is do the first vector, and then from the end of the first vector do the second vector, and then again it's from the very beginning to the end. All right, we've got to show you now the subtraction of vectors. So we're going to do u minus v. There's two ways to do it. Again, u is the vector -2, 1, and v is the vector 2, 4. All right, the first way that we're going to do u minus v. All right, the first way that we do it is we draw vector u. Okay, so here's vector u. And we draw vector v. Now the subtraction is when you start with the end of the second. You start with the end of the second and go to the end of the first. So this is right here, the vector u minus v. Okay, second way to do it is this. You start with vector u. So you do u, but instead of subtracting, we treat it as u plus a negative v. So here's what negative v would look like. Negative v would be just the opposite. So it would be at -2, -4. So right here, this is negative v. So we've got u, and we've got negative v. And in order to do the subtraction, you start at the end of the first vector and go to the end of the second. Oops, that's not looking very good. End of the first vector to the end of the second vector, this would be u minus v. This one still isn't looking very good. So I'm gonna start over on this last one here. This last one. All right, so what we got to do here is let's go ahead and draw our axis. So we start with the u first. I'm going to do a different way of showing you the addition. So there's u. And we're going to add negative v, but we add negative v to the end of u, not from the origin. So to add negative v to the end, we're going to go left 2 and down 4. But that's from here. So from here, left 2, down 4. So this right here is my negative v. So this is u, vector u, and then this is negative v. And now the subtraction would be here, u minus v. There we go. All right, so you got a couple different ways to do subtraction, just like you have a couple different ways to do addition. But in the long run, you can choose whatever method you would like. I typically like to do the where you do both of the vectors, and then you try to do your parallelogram like this, and then it's the diagonal. That's the diagonal. Now subtraction, you go from the end of v to the end of u, and that would have it. All right, so this is concluding our adding, subtracting of vectors, and also some of the main forms like component and finding magnitude. And here's your first assignment.